Welcome to the Sargassum Podcast, where we learn about the latest ideas and concepts about sargassum. This podcast is funded by the Resilience, Sustainable Energy and Marine Biodiversity Program, RESMBIT. It's financed under the 11th European Development Fund, EDF, Caribbean Overseas Countries and Territories Regional Program. RESMBIT is being implemented by expertise grants, with primary stakeholders being the 12 Caribbean overseas countries. Let's get ready to learn together.
Hey, everybody. Welcome again to the Sargassum Podcast. We have a new member with us, Miss Holly. She's going to be with us today. She's working with us on some other stuff and wanted to see what the podcast was about. And we're really happy to have y'all here. And since we last got together, Jenna, have you got any new news for us?
I do have new news. I was accepted into a PhD program, so I'll be starting in the fall. So that is very exciting.
Woohoo! Excellent. Anything you want to say real quick, Holly?
I'm really excited to be part of this, and I look forward to the conversation today.
Excellent. I'm pretty happy to be here today, and it's quite an honor for me to be introducing everybody. Usually we have somebody else do that because of my horrid accent, but today I think it's really cool to be introducing everybody. But we're here with Dr. Jeff Davis, who is an associate professor at the School of Electrical and Computer Engineering at the Georgia Institute of Technology. He's also co-director of the Grand Challenges Living and Learning Community and director of the Grand Challenges Scholar Program, which is what we're going to be talking about a little bit today. We also have over there sitting beside him is Ciera Hudson. She's a mechanical engineering student at the Georgia Institute of Technology. She has experience in multiple industries and in entrepreneurship and is currently serving as the director of the communications at the Invention Studio at Georgia Tech. Together, they are looking at the big questions that are affecting our future. And one of these is the sargassum issues in the Caribbean. Welcome.
Thank you.
And guys, to get this kicked off,
and we always start off asking everybody this one question.
Yeah, I'll kick it off. What is sargassum to you?
This is the question. So maybe I'll start first, just to give you a little history. I guess for me, sargassum has been it's kind of transformed. I spent a lot of time in the Dominican Republic. My wife is from there, and so I've been going there for 20 plus years. And at some point, sargassum for me just started off as a curiosity. We would typically spend most of the time in the capital in Santo Domingo, but a lot of times we would go out to the beach, and probably we would always go to this during the summer, so we weren't going during the winter. And so at some point, probably 2010, 2014, right, you started to see this algae, and didn't really, sometimes we would go see it, sometimes we wouldn't see it. So it was just a little bit of a curiosity at that point. But as we kept going, more and more, you see more of it, more people are talking about it. And so really for me, it kind of transformed into, a significant problem, right, that's impacting the human condition. And so that's how I guess I look at it now, is this, we like to use the term here, grand challenge, but one of the grand challenges that's really facing our planet. So.
And to me, sargassum is really interesting because we view it as this negative thing that's impacting the economy and the environment. But what's really interesting is that we don't know everything about sargassum at this point. And it really opens up a world of possibilities, because we could do all these different things with sargassum that we haven't even really fully explored yet. And so that's what our research group is focusing on. We want to take sargassum, which we have way too much of right now, and figure out if there's something that we can do with it to actually improve the human condition.
Very nice. As you know, I'm 1 hour away from the ocean, and you're 5 hours west of me. So you don't really have ready access to salt water in the ocean and whatnot. How did this sargassum research group come about?
So I can talk a little bit, I guess, about the history. It's even, we even kind of look at it, like I'm an electrical engineer. So it's even further. It's like, oh, okay, I'm not a marine biologist, not a biologist. Um, so maybe even one step further. But what happened, that really what started us thinking about the problem in a more serious way is we actually were contacted by a governmental agency in the Dominican Republic called Anamar. And so they were looking to they were basically trying to go out to different universities to get more of a connection because, it's such a big problem there. And so I was contacted, and I thought about it for a while, actually, as far as passing the just kind of passing the contact information to maybe our biology department. We have Dr. Joe Montoya here, who I think you guys are going to interview, is kind of the expert in that area. But because of the experiences that I've had with undergraduates in the Grand Challenges Living Learning community, where we basically have this philosophy that we want students to identify certain problems in the world, right? And then we want to bring together a cross-disciplinary team of those students so potentially they can look at it with fresh eyes. And so that was kind of the start. So I kind of pitched them. I said, well, we can do that, but there also might be an interesting opportunity if we want to have a lot of a student engagement in this as well, to form a team of students. So when we started, for example, we had civil and environmental engineering, we had mechanical engineering, we had someone from biology, we have a chemical engineer, and so that was kind of the we are far from the ocean, but that was kind of the start. And then from that, we sent students to the ocean. So we sent some students down to Fort Lauderdale to look at. They have a huge composting facility down there. And so we sent some students down there to learn, well, what are you guys doing with it? What are the issues? And they collected some samples for us to maybe start to do some experiments with. And then we took it one step further. We actually got a little seed grant here at Georgia Tech called the Denning Global Engagement Seed Grant. And so we used that money to put together a 10-day problem discovery trip down to the Dominican Republic. And so I went down and with four students. And one of the things we talked about the students is you can look at the research papers, but you got to go down and you got to talk to all the different stakeholders. And so we went and talked to people at universities, we talked to the government, we talked to local farmers, we talked to people associated with resorts, and really tried to give the students this understanding not only of the Dominican culture and some of the, but also the challenges that they're experiencing with the sargassum. So that was kind of that was kind of our inception, and we did the 10-day discovery trip back in August of last year.
And what are some of the research projects you guys are working on since that trip?
So right now we kind of break our research group down into 3 different projects. So the first one that we're working on is the collection of sargassum. And so one of the problems that they're having down in the Dominican Republic and other countries like that is that it's very difficult to remove the sargassum from the ocean and actually move it up the beach, because they collect it in these huge nets. They're like 500 kilograms of sargassum or something like that. And so it's very difficult to move them without using heavy machinery like an excavator, and currently that's causing a lot of cost and economic impact. So for that, we're looking into different ways that we can move that sargassum up the beach without causing as much of that negative impact. And then another project that we're looking at is bioremediation. And so that's actually using sargassum as a tool to help absorb some of the industrial waste out of water. So in the water purification process, that would be at the beginning or somewhere around there, where you would actually be able to use that sargassum as a tool to remove those impurities from the water and help in that process instead of just having to throw the sargassum away. And then the last project that we'll be talking about today is using the black soldier fly larva to actually process that sargassum and turn it into biofuel.
And that's what I want to ask you about and all, because that sounds pretty weird to me and odd, but I like people that do things differently. Me, myself, I'm developing biology textbooks written in indigenous languages. So people say that's a little bit odd too. So tell us about the soldier flies and how you're doing that.
Yeah. Um, so it is probably, I agree. It's kind of it's a very different idea. And, one of the things that we talk to the students about when they're starting to do their problem solving, a lot of different techniques, but one of the techniques is that, you really start to understand your problem, right? You start to research, understand all the nuances associated with that. And then one of the things that you can do is you can start to look at the trends in technology and society and what are kind of the popular trends. And then can you start to make a connection between those two? And so I think this kind of falls we started this, it falls in that category. If you think about black soldier fly larvae, it's a huge trend now worldwide in um, in trying to process food waste. And so as you start to think about whatever the statistics are, as far as a third of the food that we have is just wasted, is just thrown away. A lot of people are looking at that and saying, well, can we use that in a good way, right? Beyond just composting and whatnot. And the black soldier fly is very interesting because it is a super efficient at breaking down organic matter. So the enzymes that it has in its gut, and they grow extremely fast. So you can start with just this like small little larva that's hatched, and then 10 days later, if given the right food source, they become this really like little protein and lipid bar, right? That has a lot of nutrients in it. And so if you look at that trend, there's been a lot of trends, for example, in Malaysia, where they've had a lot of black soldier fly larvae, and even thinking about that protein, not just for livestock, which people do. They'll feed it to chickens, or they'll feed it to fish, right, as kind of a nutritious source. But even starting to think about feeding it as a protein source for humans as well. Now, in some cultures, people are like, "Oh no, there's no way I'm going to eat black soldier fly larvae." But that's how we started. So we started asking the questions: okay, is there a connection between these two? And so that was then the question is, well, will black soldier fly, will they eat the sargassum, right? Will they thrive on the sargassum? And so a lot of the students started doing some experiments with to answer that first question: is will they consume the sargassum? And what we did is we did an experiment where we had sargassum, and we really just fed it a lot of these black soldier fly. And we looked at the composition of the we separated out the flies, and we looked at what was left over, and we saw over a period of time that they did consume the sargassum. So we kind of like, okay, we checked that off. Right now, what we're trying to figure out is the question is, will they thrive on it, right? Is it nutritious enough that they can really grow to the full extent? And so that's kind of what we're looking at now. The other aspect of this is that, which there's a lot of controversy of the sargassum. Does it have heavy metals, right? It absorbs heavy metals, right? Or if the arsenic content, and potentially, maybe early on people were trying to eat it. I'm not sure, but potentially you have to be very careful. Like, if I'm going to put this on my crops, is there going to be accumulation of these, right? And so part of the constraint that we were looking at in this regards is that, well, it's probably not a black soldier fly that would be for human consumption. In fact, probably in the Dominican culture, that would never sell, right? But or even from an agricultural standpoint, there may be some opportunities there, but I think still you have to kind of worry about the heavy metals that the black soldier fly may absorb. And so we kind of shifted to look at, well, what is the opportunity in biofuels? And biomethane, and also biodiesel. And so that's kind of shifted our effort. And because so many people are looking at black soldier fly, there's just a ton of research out there and looking at a lot of different applications. And so, for example, there's a group in Korea, and they're looking at converting the black soldier fly into biodiesel. We've been looking a little bit, in some of the partners that we've been talking to, a little bit more at biomethane, at biogas, just because it's a little easier process for people to start to use. And some of the work in the literature actually suggests that if you use the black soldier fly as kind of the feed to your your bacteria in that anaerobic environment, that it actually the biomethane potential is pretty large. Actually, it's about 50% larger than if it was just food waste, and it's a lot larger. Maybe it depends on if you just use sargassum, which people do, right? You're using sargassum as a feeder into an anaerobic digester. It's about it can be up to like maybe even 4 to 5 times greater than just the raw sargassum. So that's kind of how we've been. That's how we've been kind of looking at this and getting involved in this. We like it because it's a very sustainable method. The black soldier fly, it's something that's accessible to small farmers. It's almost like a very low energy way to process the sargassum, right? A lot of people are like, what do we do with the sargassum, right? Can we use in that form? And if you're using too many resources to try to process it, maybe you start to lose some of those benefits. This we think is interesting because it's a very low energy aspect and of a way that we can take the process that sargassum into something else that potentially would be useful to a lot of people. So that's kind of that's kind of the nutshell, I guess, with this black soldier fly story.
Very nice. You kind of, the bioaccumulation of the heavy metal and stuff is, as soon as you started talking, that's what I started thinking about. And, but you addressed that very well. Thank you for that. And and you also, I believe, it sounds like you're trying to make this in a way where it's very easy to include local people. Is that correct?
Yes. Yeah. That's a big part of, that's one of the reasons that I kind of like this aspect where, if we can introduce this in to a system that is not just a large, chemical company that could come in from a corporate standpoint, we really kind of look at this from the ground up. And so this could be something that would be easily accessible to a local farmer, or or even a small, like a fisherman that wanted to start to grow these. They harvested the sargassum and then use that to grow the black soldier fly, and that black soldier fly larvae could actually be somewhat of a cash crop. And so I think it's inclusive of a lot of the of everyone, right, in that regards. And you don't necessarily have to have $1 million in capital, right, to get this process started. And so we really like that aspect of it.
Let me back up just a little bit to the bioaccumulation thing. Have you looked at the bioaccumulation maybe throw some of these guys under a mass spec or something and see if they're uptaking any of this stuff?
So we haven't, but there actually is research that people have already done. And so there is an indication, and there's actually an interesting point with this, is that the indication is that the black soldier fly larvae actually will uptake any heavy metals, that are in fact, some people, they haven't done the experiment with sargassum, but there's some published research with other types of algae, brown algae, and they have seen that the black soldier fly will uptake that into their body. Now, the interesting thing is that their frass or poop, right, in that regards, actually seems to come out pure, right? That it's not, that if you're looking at the excrement of the black soldier fly, that actually is doesn't have the heavy metals. And the thing that's kind of interesting about that, which I didn't mention as far as an application, is that frass, a lot of people are using that as a low-cost organic fertilizer. And so there's a lot of things that are kind of unknown, but there might be, if you could use the black soldier fly larvae in applications where it's not, getting into our food supply, right? But maybe the leftover, the frass from the black soldier fly actually could be used. I mean, it have to be tested, right? But it could be used as something that is a clean organic fertilizer that's rich in phosphorus, nitrogen. Yeah.
You just gave me about 40 new questions, and I'm going to not ask any of them at all. That's a great explanation. Thank you. Can you tell us a little bit about what this grand challenge is about?
About the grand challenge?
Yeah.
Yeah, we can. Do you want to take that or?
Sure. So, as a student, I was in Grand Challenges 2 years ago, which is a program that Jeff works on. And basically, it took you from the stage of the conception of a problem that you've noticed in the community or in the world, all the way until you start designing a solution to it at the end of the year. So you get into a group of people, and there's a lot of problem discovery. There's a lot of talking to stakeholders, and really you're trying to define the scope of a problem, and then figure out how you can address that problem and turn it into a viable solution.
We like to use the term grand challenge here, I guess, and that was it started with the National Academy of Engineering many years ago. They started off with their 14 grand challenges. Here, we almost kind of use those interchangeably if you start to think about the 17 UN Sustainability Development Goals as well. And so we're looking at projects that really have an impact on the human condition. Because a lot of times as engineers, we have a tendency to, I don't know, sometimes we get a little gadget oriented. It's like, oh, do I want to make a better laundry folding machine, right? Or do I want to try to develop a technology that can have impact in the environment, or in someone's lives? And so that's really kind of the culture that we're trying to develop here at Georgia Tech through this community, and with great students like Ciera.
So one of the things that I learned there was that, you want to start by defining the problem and not by trying to attack it with a solution. And that really applies to this project as well, because we want to figure out if there's any potential with the black soldier fly and in what capacity that could be. And then from there, we can define it into a solution or into a project where we can actually start using them to create biofuel.
That's awesome. I love that mindset of looking at these solutions and defining the problem first so you can really attack a solution. Going back to the black soldier flies, are there any concerns when you're moving these little guys around that you might transfer any kind of pathogens or diseases, to a new environment when you're introducing
So, in
them?
a short answer, no, there are not. Actually, black soldier fly are native to the Americas, so there's no problem with having invasive species of any sort. And they actually don't carry diseases. They don't bite humans, so they can't cause harm to humans or animals. And then also, they don't eat crops, so there's no potential harm to the agricultural industry. And so these little flies are just like the perfect opportunity because there's basically no negative impacts of using them in this capacity.
That's terrific. They are perfect little specimens for this.
In fact, when we were in the
great.
Dominican Republic, of course, we were kind of like, we were going all over. We were looking for black soldier fly. We didn't quite see any, but we contacted. There's a farm there which was on the northern side of the island, so we weren't able to go there. So we exchanged some communication called Taliento Farms, and so what they had been growing some of the black soldier fly, and they were growing the black soldier fly based upon they were using food waste. And then they were feeding the black soldier fly to their fish, I think, maybe tilapia. They had a kind of an aquacultural thing set up, and so yeah, it's native to the Dominican, and in fact, some people are already starting to grow it.
That's awesome. It's exciting. Ciera, engineering and mechanical engineering, probably more specifically, is a decently male-dominated field still. I can appreciate that. I'm wearing my Women in Science and Engineering hoodie for this interview for you today. What are your tips for any female identifying people in the world who are interested in STEM and or engineering in particular and just kind of getting started?
Yeah. So, I mean, first and foremost, I would say just pursue what you're interested in, regardless of what demographic is currently in that industry, regardless of how you think it's going to trend in the coming years. Just do what you want to do and don't be deterred by someone's preconceived notions of what someone who takes that career would look like. And so for me, like I was always really interested in design, and I realized that, pursuing mechanical engineering would give me the background of STEM as along with being able to work on product design. And regardless of, the fact that there might be 75% male identifying people in my classes, it was definitely the route for me to take. And so I'm very glad I did. And additionally, if you're thinking about pursuing a career in STEM and you're a female, I would highly recommend you go on LinkedIn and look up someone who's a woman in the career that you want, and just reach out to them. Just have a meeting with them, and talk to them and see what advice you can get, because they've definitely been in your position before and they can offer you a lot of good advice.
Absolutely. That's wonderful kind of way to look at it. Just do what you think you want to do and do what you love, and you'll be happy regardless. So I dig it.
May I ask another question about the Grand Challenge?
Yeah, I support that 100%. We don't have enough of that, and there's too many people that identify like me in biology and STEM, and we need a very wide diversity of everything in there, because that spice makes lots of different spices and makes everything better.
For sure.
And well, look here, I want to thank you guys for being with us today. And I've learned a lot. I hope Jenna's learned a little something. And we just really appreciate you here, and we hope to we'll let you know when this comes out. And thank you for being with us today. Is there anything you'd like to add before you go?
I think I'm good.
Yeah, just thank you for thinking about us.
Yeah, appreciate it.
And thank you for having us on.
Excellent. Thank you for being there. We appreciate you.
All right. See you
Thank
guys.
you.
Bye.
Bye.
So I don't know about you, Jenna, but I was very surprised to be talking about flies so much today. And what do you think?
I learned a lot about the black soldier fly that I did not know before. In fact, it made me giggle when he said, well, when you're thinking about the black soldier fly, and I thought, man, I've never thought about the black soldier fly before, but I loved how detailed everything was, and I loved the grand challenge. What a neat idea.
Yeah, and it was really great, and I especially like that Ciera young lady was here with us today talking about this stuff. Like you said, we need we need more representation from all groups. Not just females, but different people of color, different genders and stuff like that, and we're looking for that representation and all, and the world needs that, because everybody's almost everybody has good ideas, but everybody has something to contribute and all, and it's just really important to get more and more people involved, because there's too many people doing all this science that looks like me, and frankly, that's getting a little bit boring. And all people getting tired of it. Yeah, everybody comes up with a different, we all have different backgrounds and different perspectives when we're being raised, and we're a product of the community we're raised in, and so we bring different things to the thing, and that's a good thing, and all. So anyway, folks, thank you for being here with us again, and all, for another episode of the Sargassum Podcast. We really appreciate you, and really grateful you're here with us today. We'll see you again in a couple of weeks. Thank you very much. Bye-bye.
Thank you for tuning in today and learning with us from our guests. If you want more information about what our guests talked about today, please check our show notes for links and information in our archives. And don't forget to like and share our podcast with your friends.
The Sargassum Podcast is made possible through funding by the Resilient Sustainable Energy and Marine Biodiversity Program, RESENBIF, financed under the 11th European Development Fund, EDF, Caribbean Overseas Countries and Territories Regional Program. RESENBIF is being implemented by Expertise France, with the primary stakeholders being the 12 Caribbean overseas countries and territories. The podcast is produced by Paola Diaz, Mario Garcia Rodriguez, Cleo Maridakis, and Eloise Lopez, and it is hosted by Francisca Elmer, Jenna Contuccio, Florence Menes, Cleo Maridakis, Evelyn Salas, and Paola Diaz. We will be back in 2 weeks with another exciting guest. The music of the podcast is from the song Them I Pray by Drizzle, the Road Runner, an artist from Roatan. Follow him on Spotify or YouTube for more music.